Good day, everyone. Welcome to Chemistry with Professor John. All right, today we're doing organic chemistry. Well, this is like a makeup video for the last two videos. You probably noticed that there's no, the speaker wasn't on. Sorry about that. Not that I don't want you to hear my voice, but it just forgot to turn on the speaker. All right, guys. Here we go again. All right. Well, I already have everything written down. Okay, so we're just gonna go over them quickly. Um, all right. The For exam one, so far we talked about Lewis structure, resonances, functional group, acid base, hybridizations, and all that. That's chapter one and chapter two. Chapter three and four, we got alkanes and cycloalkanes. Exam will be 35, 40 multiple choice, plus a few free response questions and bonus questions. Okay, here's some practice questions, guys. The naming alkanes. Okay, we got here good one for you guys. I'm gonna label the main chains. Okay, in blue. So if you got a molecule like this, you want a longest carbon chains and continuous. You want to start on the sides that are closer to the first branch. If the other side also closer to the first branch, then you go for the second branch. If everything tied up nicely, then you go for alphabetical order. Okay, regardless how you number the carbon, alphabetical order always apply. So it just happened to be 2 bromo, but if bromo on the other end, you still have to name the bromo first because it's B. And then chloro, and then dimethyl, but we base on the methyl instead of a di. Di just mean 2. Okay, so we got 2 bromo, 6 chloro, 3,5 dimethyl octane. In this second one, we have 2, 3, 4, 5, 6, 7, 8. Okay, you guys see? And we got we got a promo. So you see we number 2 on the left, start from the left side because there's 2 methyl on carbon number 2, and on the right side there's only 1 branch, so that's gonna win when we number the carbons. But when we write down the name, 6, 7 promos gotta go first, and then 2,2-dimethyl octane. Okay, here we got 1, 2, 3, 4, 5, 6, and 7. All right, on the left side, 1 promo, that's the closest one you can find, right? And alphabetical order as well. So we're gonna go that way. 1 promo, 6 chloro, 2,6-dimethylheptane. Check. Another one. Now this time we're gonna go on the right side first. This is closer to the first branch, which is 1 chloro. But however, when you write it down, you still have to write bromo first. 6 bromo, 1 chloro, 2,4-dimethyl. Hexane. All right. Okay, now number 2, let's do some cyclic one. So we have 2 branches, so we put 1 on the cyclopropyl, that's just because alphabetical order, and 2 isopropyl and cyclohexane. Okay. Identify functional group. We got alcohol, we got ether, and these 2, if you notice that the methyl has swap places with the hydrogens. Okay, so that's involved breaking and forming new bonds, so they are structural isomers. More naming. When you have a cyclohexane as a branch, it's good to leave it as a branch. And then number 1, 2, 3, 4, 5, okay, carbon chains. So it's a lot easier. So that's why we have 3 bromo, 4 chloro, 1 cyclopentyl, pentane. Okay, that's alphabetical order for the branches. Here's a good one, number 5. We go 1, 2, 3, 4, 5, 6, 7. We decided to do that because it's the longest also, and it has more branches. Okay. With that, we have 3 chloros. Gotta go first, alphabetical order. 5 ethyl, 2,6-dimethyl heptane. Bicyclic. There always gonna be 2 carbons that fuse the 2 rings together. So, and then on one side, we got to check how many carbon. 4 on one side and 3 on the other side. So we're going to write the larger one first, the lower one. And then there's a direct connection between the 2. Bridge has carbon, so there's nothing in between. That's why we put a 0. That total of 9 carbon total, that's a no name. You can have a bicyclo this way with the 2 bridgehead carbon, and then there's a 1 in the middle, okay, in between. So on one side we have 3, on the other side we have 2 carbon, and then in between those 2 bridgehead carbon we have 1 carbon in between. Give us a total of 8. So bicyclo 231 octane mean 8 total. Okay, number 7 is a good one. You go all the way across from left to right. That's the longest continuous carbon chains with first branch is number 2. That's a methyl. Now when we put the name together, we just gotta put the 3 chloro first, and then 6 isopropyl, 2,5 dimethyl nonane. Okay, that's good enough for naming for now. And look at number 8. If you take the double bond, move it to the outside, and we can only do that because it's positive. Okay, positive carbon means missing a bond. Okay, regular carbon has 4 bonds. Missing a bond is positive, it's cation. Okay, so we can move that double bond to the outside. So this one will be missing a bond. Become positive, these 2 must be resonances. If we just change the orientation in 3D, the molecule on your left has 2 chloro opposite to each other, whereas the one on your right, they are on the same side. So obviously they're not the same molecules. They are cis-strength isomers or geometric isomers. If it's just simply due to rotations with the dihedral angle, just the rotations that make a difference, significant difference between, a gauge versus an anti. They are significantly different in terms of energy profile, and the anti is known to be more stable because the 2 metals are farthest away, and the gauge is a little bit less stable. These are conformable, by the way. Reaction, you can see very straightforward. We got halogenation reactions, combustion reaction. I gave you guys a couple examples of each. Okay, take notes. cracking with hydrogen and without hydrogens. You can see with hydrogens, we have both alkane. We start out with alkane. But if we don't have hydrogen, then we're going to end up with one is alkene and the other one is still alkane. Okay. Coming up, the functional group. We got ester. It has to be 2 oxygen to be an ester. Alkene, just double bond. Carbon, double bond. We got carboxylic acid. We got phenol, which is the benzene ring. Phenol is benzene with the OH anywhere on the molecule you want. Ketone, just C double bond O. Amide, double bond O, and nitrogens. Okay, NH2 or NHCH3. Amine, just nitrogens. Also, please look up other functional group like ether, alcohol, aldehyde, alkynes, stuff like that. Hybridizations, from my experience, if you got all single bond, sp3, you see a double bond, sp2, another sp2, and then triple bond, sp. Right, let's count number of pi bond and sigma bonds. Pi bond is the first bond that's formed between 2 atoms. Sigma bond, pi bond, the second bond and the third bond. Okay, so we have 3, we have 4 double bond, so that's a 4 pi bond. And we have a CH3, that's 3. In the ring we have 1, 2, 3, 4, 5. Actually 4 on the ring because this one has no hydrogens. I mean 3, that's right. 3 from the methyl, 4 from the ring. Actually, what I mean is 4 from the ring, that's for the hydrogens, and then the ring itself has 6. And you have 1, the carboxylic acid has 1, 2, and 3, and 4. Sigma bond. So 3, 6. Yep, and don't forget the hydrogen here. So that's 1, 2, 3, 4, 10, 11, 12, 13, 14 plus 3. That should be 17. Okay, and the second one there's for you, 11. Let me know if I didn't do it right. I think in the previous video I put 14, but it should be 17 for that one. And for this one, it should be 11. Okay, please also go over the exam 1 key topics and skill. And I believe that's also give you a chance to earn a bonus point. Okay. All right, guys. Thank you so much for watching. And let me know if you have any questions. Okay.